The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone. So if you can hear me out, let me know. You can let us know in the chat window if you can hear. If everything is all good. So we will be starting in next 12 minutes. But we can see that a lot of you are online. So just wait for 11 more minutes now. We'll start. In the meantime, do let us know about your background, any expectation which you have from the webinar, anything in particular which you're looking forward for. Have you worked on Kubernetes before? Do you work on microservices? Which cloud do you work on? What's your background? Do you work in Azure, maybe AWS, maybe in GCP? Or just let us know about your background as well, right? Have you worked with Docker before? Any expectation which you have from us? And we will just start in next approximately 10 minutes. So I'm new to the cloud, but I'm keen to learn. That is amazing.
Hey Stuti, tell something more about yourself. Are you already working on on-prem services, and you're new to cloud, or?
And how many of you have worked with Kubernetes before?
Yeah, that would be good to know.
If you work with microservices, or in which programming languages do you work on? What are your languages of choice? Do you work with .NET, maybe Java, Node.js, Python? Any information like that to share with us. We'll start in next 10 minutes. Okay, so I can see lots and lots of chat. I work mostly on AWS. I'm currently assigned to testing. I'm CKA certified on Docker and Kubernetes. That is amazing. And Red Hat OpenShift, okay. AWS Cloud Native. New to Azure and working on on-premise. Okay, thank you. So those who have just joined, we'll start in next 8 minutes. And we are just having a quick introduction from everyone. Do let us know about your background, any expectation which you have from us, and which technologies do you work in. So Mamta is the speaker for the day. My name is Shivam. And we'll start in 7 minutes. So just hang in with us. Need to know the depth on microservices. Okay, so working in cybersecurity, GCP is, want to learn Kubernetes, coming from the mostly working in Java or any programming language. So hi, this is Shivam. We will start in next 6 minutes. So everyone, those who have just joined, we are having a quick introduction and hi Gopal. So we already have around 126 participants already waiting for us. Are you there? Let's have a quick audio check, Gopal, if you're there.
Yes, I'm there, Shiva. Hi, everyone.
Hi everyone. So those who have just joined, kindly let us know about your background in the chat window. My name is Shivam Sharma. And Mamta will be joining us in next 5 minutes. She will be taking this session. And I also have Gopal here with me.
Hello, everyone.
Okay, so a couple of more introductions in the chat. Working as a cloud architect, want to learn Kubernetes. Good evening, everyone. So those who have just joined, we will be starting in next 3 minutes, and you can let us know about yourself in the chat window. You can tell us about your background, any expectations which you have from us, and where do you work on, which technology do you work on, have you worked with Kubernetes before, or have you worked with Docker before, or do you work in microservices, which is your favorite programming language. Good evening, everyone. We'll just start in 3 minutes. Okay, so we have Shashi, he's working as a senior developer. Hi, how are you? And okay, blockchain developer, interesting. Want to learn Kubernetes? So we have 234 participants already online. We will be starting in another 1 minute. And that's a very good number. Thanks everyone for joining. My name is Shivam Sharma. And you can quickly introduce yourself in the chat window. Hi Savio, how are you? So Gopal, I think we are on time. Let's get started within 1 minute.
Sure, Shiva.
Right? Okay. Thank you.
Okay. So Shivam, I think we can start now.
Yeah, please. We can start.
Thank you so much. Hello everyone. Well, thanks for joining in for today's webinar that is on Scalable Microservices with Kubernetes. So our speaker for today's webinar is Mamta Jha. So just to give you a quick brief on her profile, Mamta comes with a 16 plus years of experience and she has worked on different cloud platforms like AWS, Azure and Google. She has hands-on experience migrating, automating and optimizing mission-critical deployments in various cloud platforms, leveraging configuration management, CI/CD and DevOps tools like Docker and Kubernetes. Now over to you, Mamta.
Hey, hi everyone. Thanks for introducing yourself, and thanks Gopal and Shiva for handling the session. We are getting quite a few people pouring in now as well. So before we start in, just to have understanding, what's the expectation from today's session? Can we write that quickly on the chat? And tell us why do you think we should read Kubernetes, or we should have the knowledge of Kubernetes for existing in today's world? Gopal and Shivam, can anyone confirm you people can hear me? Because I see Sandeep saying he can't hear. So
I can hear you, Mamta.
okay. So maybe we can ask Sandeep to log back in. So guys, please tell me why we should read Kubernetes, or what has got you people in today here. What's interesting about Kubernetes, networking, engineering, moving into DevOps and cloud? Yusuf says that. Difference between CNI and Kubenet. Okay. Thanks for confirming that you people can hear me. Bala says he wants to get certified for the CK exam. Prashant says he wants to learn the DevOps CI/CD pipeline. Okay, cool. So quite a varied varieties of expectation from different set of people. So to just make it clear what we would be doing today, we would be discussing about a few stuffs. We would be picking up from the basics. We would be learning what would be the difference between a VM and a container. And also, let me quickly save this so that I can write down the agenda, because I don't have agenda. Okay, so we would be starting with the basics, say basics of Docker. I'll not do too much of deep dive inside Docker's architecture. Rather, we would be just trying and understanding why containers are good. And obviously, containers, it means Docker as the synonym, so we would be discussing about Docker. We would get a glimpse of Dockerfile because going ahead, quite a few number of people would have heard that Docker is getting deprecated from Kubernetes, and a lot of people keep asking that, Mamta, if Docker is deprecating from Kubernetes, like what would be left? This would be left and images would be left. So we would discuss about that. I've picked up a sample Go application, a very simple one. We would try and run that on a VM. Then we would try and run that as a container. Create an image out of it, an optimized image. And then from there, once we have the image, we take this image and move on to our Kubernetes cluster. So cluster is already up and running. So end of the day, where the cluster is running doesn't make difference. It can be an on-prem cluster. It can be a AKS cluster. It can be a EKS cluster, a GKE cluster, or OKE cluster. Anything can be the cluster type. Even you can run the same things which I'm doing on a Minikube setup as well. Only the difference would be how we access our application. So we would be discussing about that in depth. So our intention is to understand the cluster basics, the architecture of Kubernetes with respect to what's the role of master and what's the role of worker nodes in the cluster. And how do we exactly form a cluster? I'll be running you through a diagram and showing you how the packet flow would be happening. And then moving ahead, we would be discussing about how to deploy a highly available application. And if time permits, we will learn how to scale as well. And agenda today is scalable microservices. So we would do auto scaling of that. So this would be the agenda for today, and hopefully it sounds exciting to you people. So we will pick up some questions before we proceed. Hopefully people are doing good. And there's an interesting question. Bhagwan is asking that if Docker is going to deprecate, how we would be creating new images. So Docker running inside Kubernetes cluster would be deprecating. It's not that developers would not be using Docker to create images. So we would be having Docker deployed on our dev environment, in our test environment or not, but in the prod where the actual cluster is running, or in the pre-prod or the QA environment where the cluster is running, where exactly we don't create our images, we just use the images. That time we would not be having the entire full-fledged Docker running. That's the reason I mentioned that Docker is going to get deprecated. So let's start today's session. So Kopal and Shivam, are we good? Should we start today's session? I think we have hit the limit of people already.
Yes, so
okay.
we have hit the limit, and the rest of them are, I hope they join us on YouTube. And please, let's get started.
Okay, cool. Thanks a lot, Shivam. So we would be starting with our discussion about the first word. When we say today's agenda is scalable microservices, let's understand what exactly is a microservice. So we have been deploying applications. You people would have heard the word monolithic. And when we think about monolithic, it is like a single executable which gets created. So I have my front end, say the UI, or I have the client, the server, the middle tier, the back end, everything sitting together. So this was the era around 10 to 12 years back, you can say. People used to deploy everything in monolithic application, and that used to get deployed in physical servers. So there was a lot of limitations with this. Just imagine that this is Amazon type of application. One sort of database which is there, that is not sufficient to serve different sorts of things we want to do. Like I want to have a customer database, a product database, something related to customer reviews. I may not have everything looking for a relational type of data. Some could be transactional database requirements. So when we had a single database sitting in our monolithic application, it could be just one type of database, and that should serve all the different sorts of functionalities which we are trying to implement. And in the middle tier, you can think we could have, this would be our UI for our Android guys, UI for our iOS guys, UI for our web guys, a lot of different ways of entering into the system. And in this, you can think it could be a product catalog, or it could be, say, customers overview, entire data, prime database of the users, or it could be the customers' feedback. It could be, say, a lot of logic is there behind this, right? It's customer feedback. It could be handling of, say, the vendors. I was not getting up that name. So vendors list, vendor management system is there, product management system is there, customer management system is there. There is a lot of stuffs which are being placed inside a single box. And if I try to deploy this application and build this application, in fact, then I come out with a single executable, which would be normally called as artifact in the world of DevOps. I get a single bulky executable, which I need to take and I need to put that in our virtual machines, or I need to put that in our physical servers, right? So this executable, which used to get created, would be one. And when I go and deploy that in a VM, our application would be up and running. Limitations with monolithic application: if one piece of the code is not working, the entire system goes down. It's like a full downtime because of this. And scalability was not that much, because I just want to scale my front end. There are a lot of people, those who are just viewing our products, but there are not a lot of people, those who are buying. Like there is an Amazon sale for, say, yesterday was a festival in India, right? That was a holy sale on Amazon, and people were just looking into the various options or the various, they have come up with so many offers, right? Various offers. So scalability is not there, because when I have to scale the entire box. Here, multiple VMs would be scaling. And if you look at that, UI, the middle tier, the backend, the entire stuff had to scale. So that would become a bottleneck. I would have multiple databases at the backend. That would be much more confusing. Initialization of the virtual machines is one of the another bottleneck. If I have to scale up on demand very quick, that piece of thing handling is a bit difficult for us. So people thought, why not to break this and then make them reside on different servers. So from physical servers, people traverse to the era of VMs. In VMs, we have the UI separate, the middle tier separate, the backend database separate, and we have the connectivity like this. And if I want to scale, I can scale my front end separately and fit a load balancer in front of it and handle my load. This distribution helped us in managing the front end, scale them up, but still then, a lot of stuffs were there. Even if the UI was not that complicated, sometimes UI, a heavier UI can also be there. But the backend or the middle tier was one of the major pain points for us. A lot of logics were sitting together. And if I need to make change in the customer feedback system, which we are retaining and then showcasing, like this is the customer review for this product and all. If I'm making any changes in that, the showcasing mechanism or anything related to it, I need to redeploy my entire middle tier. So this redeployment used to charge us a lot. The entire system has to go down, and then we have to bring up. Then later people came up with rolling update strategy, canary deployment. There are a lot of words like floating in the market with respect to different types of deployments we could do, right? So when we look at this, it would be like a lot of logic has been made to sit together. And because of that, if I'm changing a single line, I need to develop, test, and deploy the entire stuff, the entire bulky block, and then validate. That becomes a pain point, because when I'm making changes here, it could be that it is impacting any of the smaller logics which is sitting along with it. So people thought, why not to break this further and have that logic sit separately. So when I want to break that and make them reside in separate systems, our VMs were too bigger for hosting those mini type of applications. And by the time people started to realize, people were pretty happy, and they were, I would not say that they were satisfied with the fact that we had moved from the physical server to the virtual machines era. Rather, I would say we had gone one step up, but people were still trying to figure out how we can optimize our hardware utilization more, because hardware is something which is the most costliest stuff, right? So people wanted to look for options how we can run them in smaller systems, and that is how the need of Docker started. So any containers, they took that birth from there. So let me pull that image which I was showcasing in the beginning. So let's understand the difference between a VM and a container. So here we have virtual machine, here we have containers. Both the places infrastructure is there together. You have hypervisor here. You can have OS plus hypervisor as well. So when I have an operating system plus hypervisor, actually the kernel module which resides either in the hypervisor or in the operating system virtualizes our infrastructure, the hardware, and makes it available to the VMs which are running on the same system. So this guest operating system, this OS is called as host OS, and this OS is called as the guest operating system. Let me pick a better color for this. Okay, so it would be the guest operating system which would be actually helping my applications to boot, and it would provide file system. But apart from that, any of the resources which my application actually needs, like CPU cycles, do you think this guest operating system has the capability to assign that? Answer would be no. When I have created a VM, no doubt I have defined 2 virtual CPU and 4 GB RAM as the specification or the requirement, the amount of resources given to it. Maybe in my infra, I have say 8 virtual CPU and say 32 GB RAM. I've given 2 virtual CPU, 4 GB RAM to this, 2 virtual CPU, 4 GB RAM to this, and 2 virtual CPU, 4 GB RAM to this. I have dedicated that much of resources, but the CPU cycles are not dedicated. CPU cycles would be given when that particular application or the process running inside that VM would ask for it, right? So that ability is only there with this, either the hypervisor kernel module or the operating system kernel module. Let's try to keep it simple. Let's have an OS with a kernel. So the operating system, which is the host operating system, that kernel has the capability to actually allocate resources. This host operating system kernel gives us a lot of capability, like it is helping us isolate the virtual machines. Each of the VMs are isolated in their own workspaces, and that is called as namespace. This is a kernel feature which helps us in isolating. What sort of isolation? The processes which are running inside this VM can't see this VM's processes, can't see this VM's processes. So what is that? That is a process isolation. If I mount a disk inside this virtual machine and I mount a disk on this virtual machine, they are both not visible to each other. This is like a mount isolation. They are running on the same kernel of the host operating system. I'm just magnifying this part. This is a VM for me. this is a VM, and this is a VM. So this hypervisors or the kernel module which is there, we even have a kernel namespace, an isolated kernel module prepared over there, so that whatever changes we are doing on the kernel level in one VM is not visible to the kernel of the other. Imagine in a virtual machine, do you change the system time? Do you think it is visible to all the VMs which are running on that system? Answer would be no. We can't visualize or we can't see the stuffs which are dedicated for one VM because they are isolated. So host kernel gave us the capability of isolation with the help of kernel feature called as namespace. And there was another kernel feature called the C groups or control groups, which gave us the capability to lock the resources what we can use in such type of systems. So if I have three virtual machines, I can lock in the sense I'm putting a lock on this. This VM can't use any resources beyond 2 virtual CPU, 4 GB RAM on this machine. Same way about this VM and this VM. So I'm using 2 kernel features. One is namespace and one is C groups, isolating the virtual machines environment, limiting the virtual machines environment so that my application processes are happy running inside that. That was one of the biggest advantage which we got. Guest operating system helping us application to boot and helping the application with the file system. But this guest operating system is bulky. If you take RHEL, 8 GB in size, and it needs some amount of dedicated resources for the processes of this VM to run. So out of this 2 virtual CPU, 4 GB RAM, if you really think of, our applications are very small in size. They don't need that much of resources. Resources are majorly eaten up by the guest operating system. So we moved one step towards containers, and we thought that how to optimize this. We are not seeing the guest operating system in this particular image, which is there on the right side. That doesn't mean an application running inside a container doesn't need an operating system underneath it. It does. Otherwise, my application will not boot or my application will not have the file system. So what exactly a container look like, what it is comprised of? Let's look into that. So how you have the infra here, you have the infra here as well as the first tab. Operating system is mandate because the kernel of this would be shared by all the containers. So now you can think that I may have a Windows operating system on the host. How can I share the kernel and use that inside a Ubuntu container? That thing is only possible because of this layer of the software. Like if you look, if I have a Windows host operating system, I install Docker for Windows. If I have, say, Linux operating system underneath, I install Docker for Linux. Any Linux family, Debian, Ubuntu, all those things get covered inside that. So our containerization platform, which is running here, in our case is nothing but as Docker. You can pick up a VM or you can pick up a physical server which has an operating system. You just go ahead and install Docker in it. You are good to create containers on that. Docker, what exactly is this? Docker is nothing but a ever-running server in it, like a daemon process. A process is called as daemon when it is expected never to die. So how a normal daemon is, right? So in our stories, daemon is like ever-running, evergreen, ever-living type of daemon. So daemon processes are also ever-running processes. We don't expect those processes to die at any point in time. So you just have a virtual machine or a physical server, install Docker on that, start your daemon process, and you're good to run. You're good to run containers if you have images of that. So images are very important component to create containers. If I don't have an image, I can't create a container. So what exactly is an image? An image comprises of a thin layer of the operating system, a very thin layer of the operating system, which is called as the base OS image. So if you think of RHEL 7.3 here of 8 GB, I will have some 70 MB size of that as the image. If I pick up an Ubuntu base image, it would be 70 MB in size. Think of an 8 GB operating system image residing underneath in the VM, and I'm saying that container would be having a thin layer of operating system, would be just 70 MB in size. And on top of it, you would get your application up and running with your apps running on top of it. So here you see applications binaries residing here. They are the actual containers, packages, or the software which is needed to run our application, and the actual application which is running. And the base OS is providing us the boot capability and the file system which we actually needed even when we were in virtual machine era. So this base operating system provides booting capability plus file system, and this underlying host operating system is actually giving us the kernel features, which gives us the capability to allocate resources whenever our containers need that. So when we talk about microservices, as we were talking about our Amazon type of app, we have very small services running. A customer review service could be a possibility, like, let me name it here, a customer review service, a vendor management service, a product catalog management service, say a payment type of service. So a Prime membership service, like that, there could be n number of services, but they would be very many in size, and I don't need a full-fledged VM to host them. So we would run them in containers, which would be, like people normally say, that containers are mini virtual machines, right? Why they say that? Because they have a very thin, or they are light in weight, and they are lightweighted just because the base OS is very thin. Let me clean the screen and then come up with a new page to explain you the advantages of containers. So containers are lightweight because they don't have a full-fledged operating system. So they are lightweight because of the base OS. This is the best part of it. And because they are lightweight and they have a very thin layer of operating system, their boot up time is pretty quick. Booting is fast. Because I don't have a full-fledged operating system to initialize. An entire VM initialization may take 2 to 3 minutes, and your application initialization may take, say, 80 seconds or 60 seconds. So I'm wasting my time initializing a VM rather than initializing an application, which is my agenda to host that, right? So booting is fast. And with virtual machines, when we were moving from one environment to another, it was very difficult to bake in the environment settings on that. I very well remember when I was working in Alcatel-Lucent, and when we used to pass on our virtual machines snapshots to our test team residing in Ottawa, they used to come back and say that, hey Mamta, it's not working. And we used to log in, do the environment setting again in their environment, and then our virtual machines used to come up. So it used to be very difficult to go into each type of environment and then log in and see what exactly is happening over there. So what advantages came up with containers? We also can feed in our environment settings into it and bake that in the image itself. So if I move from one environment to another, it becomes like portable. You people would have heard this word with containers. They are portable, and it's very easy. If I give you the image of my container, as it is, you can run that in your environment as well. So it becomes portable. And the biggest advantage was the resource utilization. Was the max. Why max? Because the OS was very thin. It was not sitting and eating up the maximum resources. It was eating up less resources, and that's the reason we had a lot of resources to be utilized by our application. So in the same piece of hardware, if I was able to run, say, 5 VM, now I have the capability to run same application. If I try to containerize, I may run 10 containers in the same piece of hardware. So that advantage we get when we are working with containers. So this was a brief about word microservice. So a lot of time people ask in interviews, are you running microservices or are you running containers? I would say I'm architecting my application as microservice. Sorry, I was unable to get the spelling of architecting, being a cloud architect. Okay, so microservices is the way of architecting and containers is the way of packaging our application. These days, yes, it is packaging, and we would be using Kubernetes to run and deploy, manage, and whatever, plus, a lot of benefits Kubernetes would get with that. So I'm architecting my application as microservices, packaging my application as container images, and then deploying them in a Kubernetes cluster. That would be the thing which we would be doing. So this container runtime can be different varied varieties of container runtime. Docker is one of the famous container runtimes. I have another runtimes like runc, rkt is there. Then we have containerd. A lot of varied varieties of container runtimes are there. But Docker images are the best ones. They can run in any type of runtime environment. So going ahead, you would find that people use Docker for creating images. People may not be using the entire Docker runtime in Kubernetes, but Docker would be one of the famous tools still used to create container images. The way we package our application into a container image, that's the best part of it. So not wasting much time and moving on to the demo part of it and showing you if my application is running in a VM, how do I containerize that with the help of, say, a Dockerfile. So you can think a Dockerfile is a script which helps us create container images in an automated fashion, and then we can use those images and deploy our containers. So moving on to my setup. So this is a Ubuntu server. As you can see the name of it, it's just a simple Ubuntu machine. Just let me pick up different window on my screen. Just give me a minute. Hope everything is going good. Hopefully we are answering your questions at the back end. Shivam, everything going good? Gopal?
Everything is good, Mamta.
Great. Thanks a lot. So let me start with our setup. So I have a set of files over here. I've picked up a very simple application because people would be coming for a varied varieties of language experience, or people might be coming up with no coding experience. Like few people were asking about it, that what sort of coding do I need to know? To be very frank, if we are targeting certified Kubernetes administrator, you don't need to know any coding language apart from YAML, which normally we learn through the process of learning Kubernetes. But I'm trying to showcase here that an application can be deployed on a VM and we can create images of that application in a containerized way, and then I'll take that image and deploy that in our Kubernetes cluster. So there could be varied varieties of applications which we can go ahead and deploy. So let me move into the other folder. This would be much more easier for us to understand. So I have a Dockerfile here. So when we create our images, we need to tell how to create an image. What exactly an image comprises of, we understood that the image comprises of the base operating system image with which we start our application, and then I put my apps. Like for example, I'm taking a very basic example. I want to create a Nginx web server application container. And how do I do that? I pick up a container with Ubuntu image, and on top of it, inside this container, I go ahead and I install Nginx, start the Nginx web server, and I'm good to serve my application. So this container is now having OS plus my app. And if I capture this, normally we say snapshot in the world of say virtual machines. In the world of containers, it is called as commit. If I commit this container and create an image out of it, then you would have an image, say example, I name it as image 1. Image 1 is nothing but OS plus my Nginx now. And for example, if I give this image to Shivam and Shivam creates a container out of it, how do we create a container? Let's see a sample command out of it. Docker run. I'm starting and running a container. Create and start together is done by run command. So I'm creating a container and I would start the container in one go. He wants to start the container as a daemon process as background. He doesn't want to create the container and get inside the terminal. So -d. And he would give the image name. What is the name of the image? Image name is image 1. As soon as Shivam starts this container would be up and running and he can reach the web server if he has opened the port numbers properly. So for doing that, you would find here a lot of people right here, this sort of stuffs. So when applications are running in a host machine, they are nothing but running inside the container. Sorry, it's looking pretty ugly. Let me quickly clean this up. Okay. So this is my Ethernet interface of my virtual machine, and I have an IP address associated to it. When I want to create containers, I have a network residing here. What sort of network? A bridge network. And when you create containers get your IP addresses from here. So Shivam has started a container C1 from image 1, and this container will pick up the IP address from this bridge. How does the bridge looks like? Let me show you that. So let me first show that and come back. So I have Docker here. You can execute Docker ps command and verify whether you have Docker set up in the system or not. You can even go ahead and look into the Docker daemon which is running. So I don't have any containers up and running. If I look at Docker images, could be a possibility. I have n number of images residing in the system, but I have not used any image to create a container in this. So let me see if I have a Nginx image. No. So let me create a container out of it. I would be hosting this on port number 80, and I would be creating container in as a background process with Nginx image. Let's do this. Docker ps container is up and running, and it is listening on port number 80 on this machine. So what does this -p 80:80 means? If you look at Docker network, you can find Docker network ls. You would find that there is a bridge network. Bridge network, host network, and NEN network. There are 3 types of network which gets created as soon as you start your Docker daemon in the system, the daemon process. And this bridge network is the source from where we are actually deploying our containers. So if I go and inspect my bridge, so what sort of bridge is this? This is a Linux bridge. how we have in our Linux operating system bridge, that is this bridge. So everything is on the OS level actually. And if you see here on this bridge, if you look at the network settings, it says that, hey, I'm a bridge. This is my network ID. I was created on so-and-so date, 30th March at 12:51. Scope is local and the subnet is this. This is the gateway. And if you look at the container running on the system has grabbed an IP address from this range. So 172.17.0.0/16 subnet is the subnet range. And from there, .1 is used for the gateway. So first container has picked up the first free IP address, which is of .2. Now, if I create another container, I would be creating another container without exposing a port. I don't want to have a port up and running for this. So I may create a container with, say, Redis. Redis image is not residing in the system, so Redis has been picked up from the Dockerhub, pulled and deployed a container out of it. So it's yet, yeah. So let's do Docker PS and see if our container is up. So Redis container is also up here, and here our front-end container is up. So there are two containers which are residing in the system, container C1 and container C2. C1 has got the IP address of 172.17.0.2 and this should have got 172.0.3. Container 1 is the front end, which is Nginx, and container 2 is the back end, which is Redis. Now this is connected, this bridge is connected to my Ethernet interface 0. By default, very few important points about containers. Two containers can talk to each other if they reside on the same network. So they are residing on the same network, they can talk to each other by default. Second, outgoing by default is enabled. It's also called as egress. Egress traffic by default is allowed. From the container, if I try to ping google.com, I should be able to do that. But incoming is not allowed. The second container, which is my Redis container, is a backend container. I don't need that to have an external connectivity. That's the reason, if you see, I didn't write during the Docker run statement. You just saw I did this. I didn't write -p here because I don't want to expose the port number of the container. Container 1 can talk to container 2 on 6349 on which Redis listens. How do I know that? Sorry, 6379, not 6349. So 6379, that's the default port which is used by Redis. And container 1 is listening on port number 80, but I want to reach this container from the outside world. How do I do that? If I want to get in and reach this container, this IP address is private to the system. What do I have? I have the public IP of this machine. I have the public IP of the VM. So I can reach on the VM IP address on a specific port number. And with the help of IP table rule, it's called as port forwarding. A lot of people would have heard this word, or it's called as NATing. I forward the packet to the bridge, and from the bridge it goes to the container's IP address and a port number on which the container is listening. Can I change this port number? Answer is no. This is decided by the developer. Developer expects the application is listening on 80, so I can't change this. So in my Docker run statement, if I say -d -p, first port is host port, second port is container port. This is something which is decided by the guys, those who are creating the application. And the first port is something which is empty on my system. If port number 80, no other application on the system is listening, I can say that I'm tying this up on port number 80. I reach on VM port number 80. Let me clean up this. Screen is looking too dirty. So if I reach on VM port number, VM's IP address and port number 80, that would throw me on the bridge and I would reach the container's IP address on port number 80. That's the reason 80:80. This port number is the port number on the host machine. So let me quickly grab my VM's IP address. Just hold on for that. This VM is running in my Azure Cloud account. It can run anywhere. It need not run in a cloud setup. It can run in any environment. Okay, these things are just lying here. Sorry for that. Just give me a minute. Screen is looking ugly. Yeah. So let me open a new window here and go with this IP address. It didn't copy. Welcome to Nginx page is served from inside the container. And this is, I'm reaching from outside. Why? Because I'm exposed to port number on the host. On host port 80, what is a host? The VM on which I'm running is the host, which I'm addressing as. So you say a VM, a server, or a host, all are like synonym. So I am running application inside the container, but I'm saying that on the VM, that particular container is listening on port number 80, and you can send the packet from outside world on 80 and you can reach my application. It's as simple as that. So this application which I took up is a ready-made Nginx image. This image from where can I get? I can get from hub.docker.com. So you can find, this is a public registry server which helps us in getting images from the public. So you can look for any image over here, like Nginx image. If you say, you will have n varieties of Nginx images. We normally pick up Nginx image from the official site. Do you see this? Official built by Nginx. That is always recommended to use. So we picked up this Nginx image. But tomorrow, if I have my proprietary code, how do I create an image out of it to deploy a container from it, right? Let's understand that. So that can be done in multiple ways, like a manual way of doing it. Let me clean up the screen. I'll start a container and I'll have a base operating system, which is the thin operating system. Then I'll put my application. I'll put my other packages which I need, binaries, libraries, whatever I need. And then whatever settings I want to do, I'll put everything. And then I'll commit and create an image, how I had given it to Shivam, the image one, right? So this image is my proprietary app image, say app1 image. But when I give this image to Shivam, Shivam will not be able to know, looking at the image, what are things I have done inside this. He may not be able to know what environment settings I have done inside this. He would be literally not understanding what exactly Mamta has done inside that and given it to him. So for that, there is a simpler way of addressing it. And if Shivam needs a change, he's not happy with this image, he comes back and says, hey Mamta, please modify stuffs. So what I do, by the time I have deleted this container, so I have to create one more container, put all the needed stuffs, then do the delta part of it, commit, and then come up with version 2 of the image, and then hand it over to Shivam. So what happens now, Shivam is happy, but he doesn't know literally what Mamta did. And it becomes really difficult to version control this image. I can't version control this image because I literally don't know. It's like a black box for me. Running my application, no doubt in it, but how it is doing that, I'm unaware of that. So what we do, we create a Dockerfile. Dockerfile is nothing but a script which actually codes everything what we do inside the container or we do to create a container. So when I started, if this was the Nginx application when I gave to Shivam, he did this to start the container. And what I did, I took a base operating system and I would have done apt update. Then I would have done apt install Nginx. And I would have started the Nginx daemon. So I would have started this. So few things I would have done here, that I'll write it from here. I'll write from statement, from which image am I starting? I'm starting with a base operating system image. Then I execute some commands inside this container to package this application. They are written as run statements. I execute those things or write those statements. And then finally, I say what would be my starting process with a CMD. So run would have apt update, run, another run statement may have apt install, like that. Multiple statements would be there. And then finally, I would say that start Nginx daemon. This statement would be executed during container creation. There's a difference. That's the reason I'm putting a big star, okay? This statement would be executed during containers runtime, when the container is running. Rest, all the statements are executed during creation of image. So when I give this Dockerfile to Docker daemon, I don't create an image like this. Docker daemon creates image by building and committing. So I was doing all these activities. I would no more be doing it. I would be just handing over this Dockerfile to the daemon, and daemon would be picking up, building the entire set of instructions, and then going ahead and committing and handing over the image to me. When this image is given, and instead of that image, now I write this image, say image 1, I would have a container up and running with exact same specification and Nginx server up and running in that. So you need to create images in an automated fashion. Why it is called automated? It's called automated that in case Shivam needs me to incorporate one more stuff inside that. He needs me to incorporate Vim, and he needs me to edit the default welcome page of Nginx and have a customized index.html page. Then I would have that index.html page also placed here so that I can serve that from within the container. I just write this Dockerfile by editing these 2 lines. The same Dockerfile, I'm appending or adding 2 more lines to it, rebuilding, and Docker daemon builds and commits and produces image 1 with version 2 and hands it over to us with the delta instructions inside that. So now when I give the image to Shivam, the version 2 image, Shivam understands what delta I have done because the Dockerfile is also visible to him. This file is also version controlled in our projects, and your image is also version controlled in our projects. So this image is very much needed, and this image makes us actually deploy containers. And I can have varied varieties of images. Like here, I have created an image with my Dockerfile over here. You would find that there are 2 from statements inside this. This Dockerfile is a bit optimized Dockerfile. I want to create an optimized image out of it. That's the reason I've created a multi-stage Dockerfile. If you're targeting for CKA, don't get tense looking at these. As an administrator, our responsibility is to handle the cluster. As an administrator, our responsibility is to spin up few things, no doubt in it, like monitoring application, logging application, say the basic containers which are building up our cluster, we would be doing that. But someone would be giving us an image like this prepared out of it. So that's the reason we need to understand what exactly is a Dockerfile. Some other day I'll do a deep dive on Dockerfile. Today's our agenda is to run containers in Kubernetes cluster. So I'm not doing a deep dive on it. Maybe some other webinar we would focus more on containers and we would look into the Dockerfile. So in this Dockerfile, I'm creating a Go-based application image out of it, and that image has a main function which I'm calling that would execute in the container creation step itself. So if you see here, I am starting with Golang latest image. I am copying my entire code into it, and then I'm doing a build. Go build will produce a executable output. Many times what happens, the executable which we are producing, that needs so many helping packages for building it. But those packages are really not needed when we deploy the application in a containerized environment or even in any other environment as well. So I just need the executable from that stage to get deployed my application. So here, actual container which comes up and running would be created in the second stage. The image of this would be used for deploying the application. The image from stage 1 would not be used. Stage 1 is dedicated for building the executable out of the Golang. So Go build will produce an output which is called as main. How do I know that? If you look at this -o, main. So main is the executable which has got produced, and I need that to be present in the system so that I can have my application up and running. So I'm starting with a basic Alpine image. Alpine is a very thin layer of the operating system, like 10 to 12 MB in size. A Linux flavor, but used for embedded system, very thinner compared to Ubuntu and any other OS as well. So I am installing some helping packages which would be needed for me. I'm setting a standard directory. When I get inside the container, I land inside the root. That means that. Normally when I get into the system, you normally land into the home directory. Here, if you get inside the container, you would automatically be switched to the root directory. That would be the default directory. That's the reason it's called as a working directory. And from this image, I'm copying this main and placing it inside this. So I am creating an image from an image. Okay. So this main is copied from builder. What is this builder? The stages, when you have multi-stage, you can name the stages. So from the builder stage, I'm copying this main and placing it here. And I'm saying that this application is supposed to expose port number 8080 when it is up and running. And the starting process would be the main. So once the container is up and running, the main process would be up and running. So I would create a container from this image. I would not create a container from this image. Why? Because this is a bulky image. It has n number of stuffs. It has a complete Golang latest. Golang latest image is a pretty bulky image. Let me see if I have Docker images and I can compare and show you the sizes. Then that would be helpful for you people to realize that. Nope. So let me do a Docker build and create an image. If you give this instruction, my daemon will pick up and start building the image. So here it is downloading the Golang latest. What I said, daemon would be creating a container on our behalf, doing all the stuffs, committing and handing over an image. So at present, a container at the background has started, and in that, the daemon is actually pulling the Golang latest image, and then it would do all the actions which I have mentioned, copy the code, set the working directory, go build, and produce an image and hand it over to us. So it will take a bit of time because Golang latest image is a bit bulky image. Let's see how long it is taking. Meantime, let me see if we have any questions. Let me address that. Hope things are going great. If you are doing good, can we have a quick, good, awesome, bad, not feeling happy about today's session? Can we put something in the message in the chat so that I feel happy about it or I feel concerned about it? I think people listening us on YouTube don't have the chat option, but those who have logged in from GoToWebinar have the option to post the messages. Great session, happy, not able to chat, awesome. Want some more info from the builder. So builder is just the name which I have given, Bhaskar. Builder is the name of the stage which I have given. You can give that name as a stage 1 as well. So I'm keeping you can say that I'm comprising 2 Docker files into 1 file and I'm executing. 2 froms are the 2 different Docker files which I have. One Docker file, the first part, the builder part of it, which was named as builder, is actually creating the main, the executable, building the go build command gets executed and produces a executable called as main. If you see here, this main has got executed, and this is the image, which is the temporary image which got created after stage 1, which is the builder stage. And the second stage started from step number 8. If you see, every step by steps executions have happened by the Docker daemon, and a complete output of the image has been handed over to us. So Docker images, if you do, you should find the images here. Can you guys look at this image? This image is 927 MB in size, which is the image which was produced in the intermittent state. How do I verify that? Let me quickly scroll up and show you the image ID. After step number 7, the image ID produced was 08E3C8. And if you look at this is the image size. What's the size of it? 927 MB. And the final image which is produced is 709-8D33, ED33, sorry. So this image is 14.2 MB in size. That's such a drastic shrink in the image size. And that happened only because we have picked up an Alpine image. And I've just taken the executable. So now what is there in that 14.2 MB? 14.2 MB of the image size has Alpine image and my executable. Nothing more than that. So that makes our application happy to run. But if I build it, I may need n number of other packages to really execute the go build command. But for executing the main process, I don't need them. So I have shredded all those unnecessarily unwanted packages, and my package size is now 14.2 MB over here now. So this would be picked up and we would go to our Kubernetes cluster and we would be deploying in a while. So if you see the image doesn't have a name, I can give that a name and I can push that to my Docker registry server. So here the image name is, image ID is 709ED33. I can tag the image with Docker tag command. Tag is for naming an image. Give the image ID and give a name for that image. And when we name an image, we should always name the image with a registry server /repo:/tag. I'll come to that in a while. So let me first name it. And let me name that with go to Redis and say version, say 1. This is the name of the image. If I do Docker images, my image would be named as that. Now this ID has an associated name. Why did I write it as Mamta J? And you are seeing here, a lot of places I've written too many images are having that image name as Mamta J, right? Why Mamta J? Why not something else? Because my Docker ID is Mamta J. So dockerhub.docker.com is a server where everyone can push their images if they create an account. My account's name is Mamta J, and that's my registry server's name. So any image, if you create, you name them as naming convention for an image. You just have a registry /repo. Like my repo name is Go Redis or Go app or something like that. And then you give a tag. So in this, I can have various versions. Tomorrow when I keep creating images, I'll have various versions of this. Now you can imagine, like people release Nginx version 1.17, 1.19. This is my repo. And from where I pick up, that is the registry server. So registry is the location, the server. This is the image. And this is the version. You can think like this to be more precise. Okay, the server to which you're pushing your image, and the image which you're pushing, the version of the image which you're pushing. So now if I do a Docker push, I will first have to do a Docker login. Hopefully in the system I'm already logged in, otherwise it would have prompted for my username and password. I'll do a Docker push and I'll give the name of the image which I want to push to my hub.docker.com. So let's quickly do this, and hopefully I've given version 1. So if you see this, it is pushing this image, and this image would be pushed in a while. This image is pushed. If I go to hub.docker.com and just go to my home page and look to my registries, let's do a refresh. There should be the image populating just on the top. Do you see this? Updated few seconds ago. You have the Go Redis Kubernetes image over here, and others also can go ahead and download this because this is an image which is a public image. Let me quickly give you the image name so that if someone is trying to do the lab parallelly with me, they should be able to. This is the name of the image. If you people want to pull, you people can pull that image on your system as well. And as said, you will be able to run that container in any environment. Okay, your environment is no more different than my environment because it's a container, it's portable, and it has everything what it needs to run. Now coming to the Kubernetes part, which is the most exciting part for the day. So let me pull this. Yeah. So we have a container image. Before to this, no, not going here. Let's understand what's the drawback of containers. We all understood the advantages of containers. There should be some drawbacks. That's the reason we need Kubernetes on top of it. When I ran container, you would have seen that I was running 2 containers on the same network, and they were residing on the same host machine. So Docker has a limitation that they are confined to one server. Their visibility is not behind one server. So what happens in those cases? I can't see the containers which are running in the other system. I can't communicate with another system. I have another system here. I have another set of bridge. I'm running container 1. I can't communicate like this. I can only communicate like this. So confined to a server. If Docker daemon goes down, don't you guys think these containers would die? It would. So daemon process, if it dies, all the containers in that system is washed off. So Docker daemon, you can say, is the single point of failure. And this daemon which is running, the guy is not that intelligent. Max to max, I can say -- restart in my Docker run command. And if my container stops, it would restart that. Apart from that, like, do you really think I can run a single replica of my web and have a backend Redis? If load is increasing, what do? There's no option of a load balancer. There's no option of replicas. We didn't see in the Docker run command. I never specified that I can specify run 10 containers out of this. So there is no replicas in the world of Docker. When there is no replicas, there is no scalability. You can't scale from 1 to 10, 10 to 20. You don't have high availability. Why? You are just running one. So when you're running one instance, it may go down anytime. And when it goes down and comes back up. Containers will come up in milliseconds, but you would have that millisecond downtime. So scalability, high availability, and then you have, say, what other drawbacks? So mine is a bit stuck, working for the entire day. Let me think. What else? What else do you guys think? What is the drawback? Networking is one of the drawbacks, which I said that it is confined to a single server. And single point of failure, scalability is there, high availability is there, and the most important part, management capabilities is not there. Container is up, fine. Container is down, fine. Daemon is least bothered. You have to manually go and look at it, whether it is up, whether it is down. You need to spin it up. You need to handle the management part of it. So this is not there with containers. Container is good in creating images. Container is good in running a single instance of it. You can think in a dev environment, if I want to do a POC, yeah, container is good. But if I think about prod, can I really run with a single instance of a container? No. So in such cases, it is not sufficient. That's the reason we bring a software on top of it. We say, hey, the containerization platform is good in n number of stuffs, like creating an image, and I can create containers from that image. We are good at that. But Kubernetes is good because it can manage multiple servers. Kubernetes is good because it comes to know that a single Docker daemon may go down, and if that goes down, how to have a replacement of it, we can handle with that. Kubernetes understands replicas, so it understands scalabilities. Kubernetes understands replicas, so it understands high availability. Initially itself, I can run 2 containers. C1 dash is the replica of C1. Okay. I can run multiple containers like this and they can talk to each other. So high availability is there, management capabilities are there. I can help them scale on demand. All those capabilities comes with Kubernetes. So Docker or any other containerization platform is good in creating containers, but they are not good with management of containers. And that's the reason we need software like Kubernetes to manage them. Now, that's the bit about why we would need containers. So container orchestration software, because we need to manage containers, we need to maintain them. Orchestrations means, say, automating a lot of stuffs, like someone has said, rolling updates, right? Monitoring. So a lot of stuffs when we want to automate the entire process of management, that is called as orchestration. That's the reason Kubernetes is called as a management and orchestration tool for containers. Kubernetes doesn't have intelligence to create containers. Kubernetes can manage containers created by any containerization platform. So Kubernetes would need Docker type of application underneath it to create containers. Now going back to this picture, I was very lazy to draw these 3 boxes, so I had kept it drawn. Not really. I wanted them to be in the straight line. That's the reason I had done that from before. So I would be having operating system. I would have Docker. And then I should have a Kubernetes software which will help me manage those containers. And like that, I would have several systems. It's just not one system which would be running containers. I said we would be managing several servers. What is that called as? They are called as cluster. I would be creating cluster constituting of multiple servers, and I would be running containers in them. So these containers would be actually running here in this system, say container C1, container C2. Here we would be running, and these containers would be able to communicate with each other. How they can communicate? Because we would be stitching up the network between them like this with the help of Kubernetes Network plugin, and we would get them to a single network. Before to that, let's understand. Because I'll have several nodes like this on which the actual app containers would be running, I need someone to manage them, and that node is called as a master node, a guy who manages my entire cluster. And the nodes which serve my applications are called as worker nodes. So I have two worker nodes here, worker 1 and worker 2. And master node is the one which helps me handle the entire cluster. I'll be quickly defining the processes in very precise terms, because end of the day, it's not a full-fledged training session. As you guys know, it's just a 2 hours program. So it's very difficult to compress everything and have it in a 2-hour session. So I'm trying to keep it crisp and simple, just giving 1 or 2 liners about each of the processes which are running inside the master, which makes it work as a master node. So in the master, I would have a front-end interface to which my applications or my users would talk. So a guy sitting and working on this cluster would be actually executing the commands of Kubernetes. Then it would be handled by the API server. API server is the front end of my Kubernetes cluster. All commands which we execute in the cluster would be handled by the API server. Now imagine this guy is asking me to create a Nginx container. When we were executing Docker command, my command was Docker run. When I'm executing Kubernetes command, my command would be kubectl run. So this kubectl run, and I give the image what I want to create. So I am instructing that create a container of Nginx. So API server is now confused. It has worker 1 and worker 2. How does it take a decision where to run that container? So it has another process to help him in that, and that process is called as scheduler. Scheduler runs an algorithm and decides the best fit node. So now I have 2 nodes in the cluster. Container can come here, container can come here. Scheduler will run an algorithm and find which would be the best node to host that particular container. And how will it find that? It will look for, say, the least loaded node. It will try to maintain high availability of your application, and it would be running an algorithm finding the best fit node. Like C1 and C2 is placed here, C3 is here. Your container Nginx is called a C4. So don't you guys think C4 should be the good candidate for worker node 1? So this scheduler runs that algorithm and will hand over worker node 1. But how will the scheduler know that C1 and C2 and C3 are running on worker node 2 or 1? That information is with whom? Is it with API server? Answer is no. It's not with API server. It is with a database which is residing on the master. It's called as a key value store. A distributed database, entire cluster configuration resides here. So API server receives this request. Let me write it as 1. It first goes and fetches what is the present state of the cluster and comes back. So here in etcd, it is written that worker node 1 is having container 3 and worker node 2 is having container 1 and container 2. Some people might be thinking, those who are aware of terminology pod, that why Mamta is addressing like a container. I would introduce pod in a while, so just hold on for that. In case you're confused why we are talking about containers, then it would make a lot of sense in a minute. So point number 2, the second message went, it found out what is running where, came back to the API server, and with that information, it went to the scheduler. So this message which goes to the scheduler has 2 bits of information, what is running where and what you need to spin. So it will run that algorithm, find out what would be the best node for it, and then return that information to your worker node 1. Once that information is grabbed by the API server should go and connect to that node in the cluster and give that instruction. What is running in this cluster worker node which listens to the master? The component which is running is called as kubelet. So kubelet residing in the worker node picks up that instruction, goes to and talks to Docker. And that in turn goes to the operating system. On this level, it is a process. On this level, it is a container. On this level, it is a pod actually. So Docker creates a container, but Kubernetes doesn't understand what exactly is a container. Container terminology is not a Kubernetes terminology. So it wraps up that container in the terminology it understands. But why they couldn't make Kubernetes understand about containers? Not a big deal about it, right? We could have given that intelligence in Kubernetes and told that, hey, understand this is a component or this is an object. But I can run RKT containers. I can run containerd containers. Don't you think if with every runtime, this Kubernetes had to understand different sorts of containers, it would be difficult on this poor guy who is sitting here and executing the Kubernetes commands to handle them. So they kept containers a bit abstracted from us, from the Kubernetes guys. They told that you run Kubernetes commands, whether it is running a RKT container, whether it is running a Kubernetes, a containerd container, Docker container, doesn't matter. From Kubernetes point of view, you will always call it as a pod. And the underlying containerized environment understand that this is the container. And kubelet abstracts that from us. If it is running Docker container, kubelet will translate it to Docker run command. If it is running containerd container, it will instruct that in containerd terms to create a process and call a container. So kubelet is giving us that abstraction layer and starts this pod or the container. So here the pod comes up and running. What would happen? Kubelet gets that up and running. It has followed the instruction of the master. So here this would be message number 4. Response should come back. This should be message number 5. This should be message number 6. Step number 7, container spinning up and a wrapper pod over there. Now the response has to go back saying API server that, hey, whatever instruction you had given, that container is up and running. And now, once this instruction has come back, your step number 8 would be that API server goes and writes that container 4 pod 1 is running in worker node 1. Why writing this is important? This is important because another guy runs another container in the system, my database should be up to date. So this database helps us manage the entire system. So we normally have a disk mounted to it so that we have persistency in the data. So this would be there in a volume which would be mounted, and we would be taking backup of the volume time to time and creating persistency so that I don't lose anything. If you have lost your etcd, you have nothing in your cluster. You are destroyed. Your cluster will not make sense. Now I skipped quite a few number of things. How to create this cluster, that part I have not covered. Maybe we would do that some other day. And I have even not mentioned how we would bring them in the same talking terminology, right? How they can communicate with each other. Little bit focusing on that. So let me save this. Maybe I may need this in a while. So hopefully people are good with the architecture. Kubelet is a daemon which is running as a guy who captures the instruction, listens to the master, and executes the Docker run command on our behalf. End of the day, Karthik had a question, so picking up just a few questions because I'm seeing a lot of questions are pouring in. So Kubelet takes the responsibility on that particular node to go and spin up the containers, Karthik, and that would be executing the Docker run command on our behalf. Because there are n number of servers, being a user, I can't get into 10 servers and say Docker run, Docker run, Docker run, right? So I say kubectl run. Kubelet takes up that kubectl run, translates that to Docker run, creates a container. Because container can be of n different types, we are putting a wrapper on top of it and calling it as a pod on the level of Kubernetes, so that whatever type of container is running underneath it, it's abstracted from us. We are not breaking our head with what exactly container runtime is residing inside that. For us, we are just executing Kubernetes commands. So pod is like a wrapper on top of a container. It can be one container, it can be multiple container. Not complicating the stuffs because this is the initial stuffs which we are learning. So there are n number of things. Okay, Kubernetes is like an ocean. I can be on and on speaking about it for days together, but because we have confined time of 2 hours, just understand that pod is like a wrapper on top of containers so that Kubernetes can manage that. Kubelet understands pod and Docker understands the container. Hopefully we understand this. Isha is asking how scheduler is sending its result to whom after calculating the best fit node. So scheduler is sending the result to the API server. So API server is the server and rest all processes are client, Isha. So it would be executing the algorithm to find the best fit node depending on the load balancing techniques. All the worker nodes in the cluster should be equally load balanced. It will look into those varieties of things, or you would be very specific, like Isha is saying that no, my container 4 should come up in worker 2. You have given a constraint, and scheduler will say, okay boss, and place your container on worker node 2 in case it has resources on that. In case not, it would not be able to obey your or align with your constraints. So it looks into those stuffs, finds the best fit node, and replies back to the API server. So if you look, API server is talking to etcd, API server is talking to scheduler, API server is talking to the users, talking from outside the cluster, API server is talking to the worker node, Kubelet. So API server is the single point of contact on the master to whom everyone talks. No other process has any other communication outside. Neither with the worker, neither with any other process. If any two processes are talking, they are not talking directly. Like some information was needed by the scheduler, but API server fetched that from etcd and gave that to the scheduler. It's not like scheduler goes and fetches that from etcd. So everyone goes via API server for all the communication. Now bringing the controller, Puneet is asking that question. I was going right there. Now if you have created a pod is not good. Pod is not good in the sense pod is equivalent to a container. When I say pod is equivalent to a container, container dying, daemon not bothered, pod dying, daemon not bothered. So it doesn't give high availability, it doesn't give replica concept as well. So you don't have the ability to deploy applications and make them up and running. Let me see if I have any sample of a pod. Then let me pick up that and show you. So I have a demo pod.yaml file here. I'm creating a pod, and this is the name of the pod and the label associated to it. Every resource in the world of Kubernetes has a label. If you come for Kubernetes classes, we teach you how to write this YAML files. I'm just running through them now, but you would be learning how to write them. I'm creating a container named demo container with name image coming in Nginx. So how I had deployed a container in the system, I'm going to deploy a container in my Kubernetes cluster. Now your question may be, where's your Kubernetes cluster? I have my Kubernetes 2-node cluster running in AKS at present. I don't have master with that. And if I want to create a demo pod.yaml, I can go ahead and say create command with -f. What does -f means? -f means the file. I'm giving the file. Whatever resource is defined in this file, go ahead and create that in the cluster. That is the meaning of it. So if I want to list the pods, I can do kubectl get pods, and you can see my pod is up and running. You can even look at in which node in the cluster it is up and running with -o wide command. It is running on worker node 1. Worker node 0 and worker node 1, 2 nodes were there. How in our picture we had 1 and 2, here it is labeled as 0 and 1. Now this application is having an internal IP address. I don't have the capability to connect to this application unless and until I expose this application outside the cluster. So to expose this application, we will have to bring one more component into picture, which is called a service. So you say kubectl expose. What you want to expose? I want to expose a pod. Then you give the name of the pod, say demo-pod. On which port number it would be listening. On the, how do I explain? Let me first type in and let me take you back to my diagram and explain you there. I would say on port number 80 inside the container, and there is a type associated. In cloud, you have a type called as load balancer. So let me first create this. Okay, B has to be capital, my bad. So I have created a service associated to it. So now let's understand what's a service. Hopefully this is saved. So let's go to the networking part. So you create a pod. What was the capabilities of container? That if a container is residing in the same network, it can talk to each other, right? So here, one container, pod 1, can reside on worker node 1, and say pod 2 can reside on worker node 2. But they would be able to talk to each other. But why? Because they are in the same network. How they came into the same network? Even if this is running on a different node in the cluster and this is running on a different node in the cluster, they can talk to each other because this connectivity may not be there. It's not good that I connect them like this. So let me just erase this line. Yes. So what we know, there is a bridge type of networking here. There is a bridge type of networking here from where they get their IP addresses. These IP addresses are local or private to the system. So pods get private IP addresses. If you want to connect two bridges in a real-time environment, what do? You get a gateway type of bridge. So you can think there is a network connecting these bridges. And this network, a lot of people call as overlay network. It's over the normal network. That's the reason overlay network. Just give me a second. Let me sip some water. Sorry for that. So there is an overlay network and there is bridge type of network over here. This bridge network and this bridge network. And containers which reside in the same network on the same bridge, like I have, say, container pod 3. They can talk directly like this because the IP addresses are the same bridge. But if the packet has to go out, so containers residing on this node, let me pick a real-time example. The container residing on this node had got 10.244.1.5, okay? So let me say my packet has to go to 10.244.1.5. And the IP addresses on this node would be 10.244.2.0, for example. So this guy would get an IP address of 10.244.2.6. This gets 10.244.2.7. So when 10.244.2.6 sends a packet to 10.244.2.7, it's just like this. Packet doesn't go out. When it falls on the bridge, it understands it's the packet on the same node, so it forwards that. But if it wants to send a packet to 10.244.1.5, when it comes to this bridge, it understands that, hey, it's not an IP address of my range. So what should I do? I should put that to the overlay network. Here it identifies on which node this range is there. 244.1. Worker node 1. This is worker node 2. It sends that packet to this node. When it falls on the bridge, 10.244.1.5 is reachable. So this way I'm able to connect to my application. But one of the biggest drawbacks of containers and even the pods, they can't retain their IP addresses. IP address is not static. So just imagine that you want me to send, I have a application running in a server whose IP address keeps changing. I have kept another static IP and I say that, hey, say for example, Nupur is sending me the packet and I say, Nupur, you always send it to say 10.10.10.5 or some IP like this, okay? And from there, I would figure out how I actually send it to my application. So I can grab a static IP address and I can say that you send it to this and we will figure out how it forwards. So it's my responsibility to figure out where my application is running, but it's not Nupur's responsibility to figure out where my application is running. Now replace Nupur, sorry Nupur for replacing you, with app A and me by app B. So when app A wants to talk to app B's IP address is not static. How will it send the packet? If app B restarts and comes up, IP address is changed. How will it know where exactly is, what is the IP address of app B? It could be a possibility that it was residing on one node. Now it has come up on a different node. Could be a possibility. When the recreation request comes, scheduler can choose a worker node, different worker node. So IP address range might be different. So in such cases, this IP is not static. That is the reason we would be actually bringing up one more static IP address in between, which is called as service. I'm saying that I'm grabbing a static IP address, and on port number 80 of that, if you send the packet, I'll figure out how to send the packet to my application. and this is my pod's IP address and containers port number. So that is what I did over here. I mentioned that I am exposing my application, and on the service I'll receive the packet on port number 80, and I would forward the packet to port number 80 of your container. And I'm creating a type load balancer. Just to keep it precise, if I want to expose my application outside the cluster, I need to grab an external IP address from my service, and that I have done over here. Load balancers can be created in cloud automatically if you have the cloud load balancer enabled. In case of on-prem, you will have to use a metal load balancer. So now how the packet is flowing? You would come to load balancer's IP address. From there, it will come to the VM IP address. From there, it will come to the static service IP address which you have got with the port number 80, and from there it will forward it to the pod's IP to the container port 80. So you specified this as -- port. You specified this as -- target -port in the command. IP addresses are dynamically created for the service, allocated but static in nature. Pod's IP address is anyways there. Now you tell me load balancer should send the packet on a specific port number, otherwise how will I know that when the packet is coming, it is coming for which pod, right? So I grab a node port. When we want to expose our application outside the cluster, we had tagged a port number. Remember we did initially with docker run command, say -p80:80. This was host port, right? This is that host port I'm talking about. Host word in the world of Kubernetes is called as node. So I'm talking about that particular node. Now, here, this is the IP address external. This is the port number I would forward to on the node. And then this is the service port number. And this is the service IP address and the port number. I can even show you that it understands that I need to send the packet to the pod. How does it know that? Let's figure out this. Can you see here? The endpoint. What's the endpoint? kubectl get pods command output is visible here on the top, if you people can see. IP address of the pod is 10.244.1.5. That is the IP address of your endpoint. So service is receiving packet on this IP address and forwarding on this IP address. And this is the external IP address. If I pick this IP address and go to my browser, I'll be able to access my application. So this connectivity is being stitched because of this external overlay network which we have stitched. And someone was asking again and again, what's the difference between Cubenet and Cni? So Cubenet is the Kubernetes networking, the networking for connecting multiple networks. Like that, there are multiple container network interface like Flannel, Calico, Contiv, WeaveNet, n number of plugins are there. Kubernetes doesn't have network inbuilt in it. Networking is not packaged with it. So you can get any third-party plugin and say, create your networking on top of it. So what sort of networking? I need BGP type of networking, VLAN type of networking, VXLAN type of networking, like Multus. It's very famous. I come from a telecom background. So Multus is very famous. We need multi-NIC cards. So multiple Ethernet interfaces has to be there. So a lot of plugins are there which you can just pick and apply, and your networking would get stitched up. As soon as the networking stitched up, now you see when my pod 2 is talking to pod 1, packet would flow without any translation, because every pod can talk to every other pod in the cluster with IP address. Even though the IP address is not static, it is reachable, it is resolvable across the cluster, just because the entire cluster becomes one network on applying the CNI. So what advantage does the CNI get? CNI brings your cluster into a single network. So when you apply CNI, all worker node, master, all of them come to a single network like this. And whatever I'm creating here can talk to each other just like that. Without any translation, the communications can happen. That's the beauty of CNI. Which type of, say, packaging you need, that's sort of plugin you would be installing. Like if I want to do with a BGP, I'll be going with Calico. That Flannel is a simple VLAN type of networking. So depending on the type of networking, we would be incorporating or using that particular CNI. So this was about that. And the important part here, a pod to pod communication never happens because two pods are not having a static IP address. So when pod B talks to pod A, I'll get a static IP address fixed in front of it. And when pod A also talks, I'll have a corresponding service A, and you can say service B. So when pod A talks, it will go like this. And when pod B talks, it will not come via the service. It will go like this. So when you have your application running, like let me show you this. This application you saw, it's a simple one. It is up and running. Hopefully this. I want to show you, okay, the deployment folder. I have a Redis application which I'm deploying like this. Now you would say Mamta didn't talk about deployment, and yes, you guys are right if you're thinking so. Okay, so I am creating a Redis pod here, but I'm creating replicas of it. And when we create multiple replicas, here I'm just creating one replica. Still then I have created a controller associated to it. Let's understand what exactly is a controller. I have some time. So guys, it may shoot up a bit. You will have to show some patience in case you're grasping some knowledge. Hopefully exceeding by 10-20 minutes should not be a problem for you guys. Hope you guys are enjoying the session. Okay, so controller resides in master, first thing. And its responsibility is to make sure a pod is up and running. So if I have an Nginx pod, I will create service on the data plane side so that I can receive packet, and I'll create an Nginx controller. Mind it, I'm saying I'll create an Nginx controller so that I can sit and just manage Nginx pod. Now, if I have Redis pod, I'll create a Redis controller as well. So let me add on this. I'll create a controller as well, Redis controller, and I'll create a Nginx controller. Work of the controller is to make sure that how many of the replicas you're creating, they should be up and running. And if you want to scale, you can scale them, okay? Instead of one replica, if I want to run multiple replicas, I can even do that. So here, if you see, I'm creating a deployment controller. Deployment is a type of controller which is used for applications to be highly available and scalable, manually scalable, mind it. So here I am creating container. You can see I'm creating a Redis container, and I've specified some resources, how much of CPU, how much of memory I would need, on port number on which it would be listening, and I have some set of labels for it. Labels are used for identification purpose. A service identifies a pod with the help of label to figure out which pod should I transmit the packet to. So here I'm creating a service, and I would be going ahead and creating the service which would be listening on 6379. But the service which I would be creating for Redis, let me go ahead and create this and show that to you. I'll have to specify the file whose resources I'm creating. So kubectl get pods. If I do, I should have the Redis pod up and running. And similarly, I've created a deployment, so I can go ahead and do deployment as well. I have created a service as well. You saw I had written two things inside the same file by dividing by an hyphen in between. In case you guys didn't notice, just look at it. Two definitions can be written in the same file by dividing that by 3 hyphens. Here I'm creating a kind service, and here I'm on the top I'm creating a kind deployment. With 3 hyphens, you specify that you are starting a different kind of resource creation. So Redis is not having an external IP address because Redis will not get exposed outside. Redis will only be needed to communicate from internal within the cluster, right? That's the reason it doesn't have an IP address externally. But this is the Redis internal IP address, and it would forward packet to Redis pod. Let's describe and see if it understands that which is Redis pod it has to forward the packet to. Yes. Endpoint is populated, and that endpoint is this pod's endpoint. Well and good, all sorted with Redis. Let me create another front-end application. I don't remember the name of the file. Okay, awesome. Let me cap that file and show that to you so that at least you know what I'm creating. I'm creating a front-end Go application. You had seen me creating this Go Redis app. That I'm picking up, and I'm creating a front-end application. I'll create 3 replicas of it. I'm creating a deployment type of controller. So how our picture will look like, let's visualize that. So I'll have a Go app, 3 replicas, distributed across different worker nodes, maybe worker 1, and worker 2. I'll create a service which will expose this outside the cluster. And because I create a load balancer type, I'll have a load balancer. My users will reach here. Okay. Let me draw some hairs as well on the top of the head. And it will go to the service. From here, it will route the packet. When we have multiple replicas, service has the intelligence of distributing the workload, load balancing. Backend, let me draw with a different color. This is service of my backend Redis, and this is my Redis replica. Oh man. Okay. So whenever the Go application wants to reach, it would reach this way. Okay. So all the front ends communicating with the backend like this. And when Redis wants to reply back, this would be the architecture. This service is not exposed outside. This service is exposed outside. This is what we are doing. Hopefully we have understood what we are trying to deploy. This is not going to be a stateful application. We are deploying a stateless application. Okay. And we have in fact deployed that. So now if I do kubectl get pods, I should have 3 replicas of my front end. I should do deployment, then I should have 2 deployments now. Now you can see it is saying 3/3, and I should have service as well. So if you look at the service has a load balancer's IP address. Let's try reaching it and see what we are able to visualize. So my application is expecting packet. If you see here, 9090 is the port number on the load balancer. So if I go and browse this, it will tell me that this particular link is not there. You need to hit /code. What is this application? I've opened that as well. So you can see there is a website called as theysaidso.com. boring but a good website with respect to quotations for the day. Okay, inspirational quotes, management quote, life quote, a lot of different types of quotations you can find here. And they expose APIs outside. I am accessing this API and it showcases me the my website would be showing the quotation of the day. If you look at it, you will see that you will never win if you never begin, and it's the time to begin your Kubernetes journey as well, right? So it's sounding so much in sync with our journey. So here you can see it's the inspirational quote which has picked up and it is showcasing on the website. So this is being fetched and it is running from my container now. Let me give you the link. If people want to access my application, they can go ahead and do that. Let's understand what exactly it does. So Redis is a caching application. It caches the data and front-end application showcases that data. This is my front-end application. So first time, how did it fetch? First time when you tried opening the app, it understood that it went and saw Redis doesn't have anything in the cache. So it made the call to the web page of theysaidso.com. Okay. It grabbed that and it saved that in the Redis cache. From next time onwards, for this quotation is valid for 24 hours. Next day the quotation would change. So if you are having your n number of times when you are trying to browse now, it is serving from the Redis cache. But first time when we are hitting, it is going and grabbing the data from the website. So here, if you can see, I'm running 3 replicas. If a lot of people are accessing my application, I should be able to handle that. And I had mentioned that Kubernetes controller deployment helps us in scaling, but manually. So I'll just show you the scale. I want to scale. What do I want to scale? I want to scale my deployment. Which deployment? My Go Redis app deployment. And how many replicas I want to have? I want to have 7 replicas. Let's see. It would be so quick, you won't imagine. Can you guys see that? It's so amazing. Within milliseconds, we are running 7 replicas of my front-end application. The last one alone is a Redis master. Apart from that, it's all your scaled front-end application. Now, n number of people in this webinar try to access my application, would be serving all of them. Would not be troubled because I have multiple replicas in the front end. So I can scale them, but remember, deployment controller doesn't support auto scaling. It supports manual scale. So I can scale them in a manual way. So what's the responsibility of a controller? Controller has 7 replicas now. Its responsibility is to make sure that 7 of them are up and running. Can we just try out that it self-heals itself? Let's do that. Intentionally, I go and delete a pod. Let's see what happens if I delete a pod. I'm deleting this first pod. By the time you come back, you would find out that already 7 of them are up and running. A replacement pod has already come up. So here you can look at it. Which one is the youngest one? This one is the youngest one. So this is the replacement pod. So if I just create a kind pod, like I did for the demo pod, right? If you do kubectl get pods, which I've done here, demo pod was created as kind pod. If I just go ahead and delete demo pod, say pod demo -pod, no one would be bothered in the entire cluster. It's just terminated. It's terminating and it will never come up. If I don't have a controller associated to it, no one is bothered about it. So we normally create a controller, not normally create, we have to create a controller which would be residing on the master. I would have a Go controller and I will have a separate Redis controller residing on the master, whose responsibility is just to keep noticing that these guys are up and running. If they are up and running, well and good, it'll make sure that they are running. In case they go down, they would bring them back up again. So this was all about today's session. I didn't even open one up, not even one single slide of mine, but yeah, I'll do one thing. I'll show the thank you slide of mine, because with a lot of effort I had prepared, but somehow I was busy drawing and explaining. Hopefully you people had a good session.
Thank you, Mamta. Thanks for the
How was it,
informative
Shivam?
session.
It was good. People are enjoying.
Yeah, we have a house full, and there are a lot of questions for you in the
Nice.
chat as well.
Yeah. Yeah, we
And
will
in
do
the
one thing.
meantime,
Yeah, we would answer them at the back end. We would not close the session. We would reply them at the back end. But before to that, you want
Sure.
to specify something else, then please go ahead.
yeah, so if you can just change the slide, if you can just go next.
Okay, sure. Okay, about the training.
So-
Yeah.
Yeah, so everyone, there is a training planned on CKA, Certified Kubernetes Administrator, and the batch will start on May 1st. And if you can go to the next page, the training will be distributed over 8 weekends. We'll having 16 days of training and 4 hours every day. The timing of the training will be 7:30 p.m. IST. And Mamta, why don't you walk us through the outline which you have created,
Yeah, sure.
and just tell us about the various topics which we'll be covering in the training, a little overview about that. Thank
Sure.
you.
Thanks, Shivam. So yeah, I see there are a lot of questions regarding the training. That's the reason Shivam wants me to give a glimpse of what exactly we do in the training program. So we have been running this training program in corporate and few other forums for quite a few number of years now, almost around 4 years, I would say. We are coming up with the next batch of ours on May 1st. And we would be covering certified Kubernetes administrators, basic points which is asked in the exam. But plus with that, we try to cover a few things from the job perspective as well, so that when you are looking for a job change, you're ready for the job as well. So we start up with creation of a cluster. Everyone learns how to create a cluster, master, worker node. I just gave a brief overview about today about a glimpse about the processes which are running. We go in depth into that. We set up our cluster using a kubeadm tool. Then we learn about what exactly is a pod, how do we create, and we understand about the basic processes like etcd API server, how do we work with them. We learn how to code in YAML, and then we learn about networking basics. How do the networking happens inside? A lot of people were asking about CNI. There are different types of services which we can create. When we have a lot of load balancer type of service created, advanced networking can be incorporated into that, called as in Grace controller. We discuss about that as well. And because there are a lot of services running, microservices running, core DNS is the one which resolves the domain. Name resolution is done by that. So if I name a service, it will give me the IP address of that. So we discuss about that. We discuss about deployment. I just showed you today one basic feature that it is maintaining the number of replicas. We learned how to roll out new versions of the software using it. We learn how to do auto scaling. We learn how to incorporate configuration changes into our containers, how to supply encrypted secrets into our containers. Multi-containers pods are very famous these days. So after every point, we try to bring some real time. If you see the last point in the slide deck, deploying real-time multi-container stack. So we try to get some real-time examples so that you're getting ready along with the exam. We also get them prepared for the job as well. Advanced scheduling, persistent storage, getting persistency inside our container, how to do maintenance of our cluster, how to upgrade our cluster, how to restore our cluster back in case something happens. I was talking HCD is one of the major roles in the Kubernetes cluster. So we take a backup of that, we restore them. All those things we would be discussing. We cover very little bit about Kubernetes security as well from CK perspective. Kubernetes CNCF has come up with a separate security certification as well, right? So here a little bit glimpse about basic things needed about the security, like network policing, creating roles, managing roles, confining people to do only certain set of actions on them that we do. And because we are learning certified administrator course, troubleshooting of the cluster, troubleshooting of various component failures becomes an important part of it. How does the logging happen? That also we discuss about. So we discuss about quite a few number of things. And from the job readiness perspective, stateful set, daemon set controllers are not covered as part of CK, but we do that because every application can't be deployed as a deployment controller. There are various varieties of controllers in Kubernetes, and application is classified on the basis of the controller. So we cover that as well, and we also help you deploy a complete log aggregation stack with Elasticsearch, Logstash, Kibana with FileBeat. We also prepare you for exam with 2 set of questions, and how does the exam environment look like, because a lot of people might be giving exam after a long time. It's a practical 2 hours exam, so that takes a little bit of people get a bit stressed with that. So we also try to give you a feeling how the exam would look like in the exam prep days. So this we try to cover in our 8 weeks program. And yeah, Shivam, that was the outline part of it.
Thanks for walking us through the outline. And some of the participants or some of the attendees are asking about how are we going to do the labs, or how much percentage of labs will be there in the training of CKA?
Yeah, so it's a complete hands-on course. Like today, how you understood a little bit of architecture. Once you have understood the architecture and you have started to deploy stuffs, a little bit of Docker theory would be there, then Kubernetes theory would be there. And after that, it would be like a topic. I teach you deployment controller, we go and deploy that. I show the demo, you take few things as homework, few things you do in the class along with me. And we have, Shivam, you know that we would be having an active WhatsApp session. So they can post in their questions in that as well. So that if during the week they are doing some lab exercises, they can get back to us. And on high priority, we would help them out with that as well. So it's a pure hands-on session because exam is also hands-on. So it's a hardcore hands-on type of training.
Right, so that's the training will be totally hands-on. And if you go and check it out in the chat window, there are some links regarding how do you reach out to us, how can you drop us and inquire about the training more. And if you can find the public chat, the details will be there. And the trainer for the session is Mamta, as you can already see in the slide deck. If there is any other question regarding the training, you can let us know.
Shivam, I don't see Kopal posting the training page or anything like that. It's just stay tuned with an upcoming webinar, our DP100 webinar link. Kopal, do you plan to post any other link with which they can get that information?
All the links have been posted before this.
Okay.
So I did share the YouTube link, the course page, everything with the participants.
To the entire audience, is it? Okay, I don't know. Somehow I'm not able to see that. Okay.
I did.
Okay.
So cool. I'll just replace them.
They do have the starting date of the training as well, which is May 1st.
Okay, cool. So you can pass on your number, which is handy. You guys can reach Kopal. You can reach us on LinkedIn in case you are interested in our session. And yeah. So it would be Yes, sorry, Shivam.
Sorry, just want to walk us through the participants' feedback. So if you can see that these are the feedbacks which we have received from the previous trainings which Mamta has delivered, and pretty interesting, amazing feedback which we have received. I just want to read maybe a couple of them. So there is a feedback from Ankush that we have worked with Mamta on the cloud architect for Decoder, and she has been a great consultant and a mentor in our journey to rewrite our architecture to solve our complex use case with Decoder and supporting multiple files project execution in Docker containers and orchestration managed using Kubernetes. So these are some of the consulting feedback which Mamta receives in her, we can say, in the consultancy versus and along with in the training as well. So everything which we cover in the training is something which we have or she has done previously, and everything is hands-on oriented, everything is production aligned, and that's how we everything you learn in the training can be applied on the next day in production as well. So there are some other amazing feedbacks as well. We have from Sitesh and Pallav.
So these are few to
And if you
quote, yeah, and some features about it. Like a lot of people get tensed. How many participants would be there? What would be the batch size? How would we doing the lab exercises and all? So I just want you guys to come up with an open mind with a single cloud account. Apart from that, leave rest to us. In case you understand what is a CPU, what is a memory, what is a disk, and you can run some commands. We can handhold you and make you learn about Kubernetes from the start. So it's a tough journey, but we try to make it easier for you people to learn that and sail in that in a better way. So these are some of the handy numbers. Mangesh is saying some link is not clickable. Mangesh, can you be precise which link is not clickable? And we are running a 10% off today. Whoever has enrolled for this webinar, if they are enrolling today, then they would be getting the course in 10% off.
So there is a question for you, Mamta, that I have already gone through the CKA training. Will you guys help on preparing CKA exam from the exams point of view?
So
I think I've already answered that, yeah, but if you can just give
so
two-liner
we
on
would
that.
help you prepare from exam point of view as well and from job point of view as well, Tyagarajan, in case you are planning to jump into a Kubernetes project in your office to a different project, or you want to look for a job change, it would be helpful in that as well. So I'm not sure with whom you have gone for a CKA training, but yes, this training would help you prepare for both the stuffs. Shivam, are you able to see the link of the enrollment if you have it handy? Quite a few people are asking about it, if we can post them. They want to enroll today and they get the 10% off. So the link which we are sharing is already discounted and it's a 10% off link. Shivam, you can hear me?
Yes, so link is now going in the chat window.
Okay.
So I have just pasted a link in the chat window. If you can confirm that you can reach out to that link, it should be clickable.
The link is working. In fact, I can showcase that on the screen itself. I don't know why few people are saying the link is not working. Oh, sorry. So this is the link which Shivam has posted. This is for the enrollment. It's already 10% discounted link which we have for today. So meantime, if you people have any questions for me, you can post. I'm just looking into some questions and would be replying. So I'll just read through the questions as well. Astha is asking, do we have HPA for auto-scaling? Answer is yes. Is there any training plan with EKS-based clusters? So yeah, that reminds me of something good and interesting. So guys, we are coming up with various programs, like we are coming up with a dedicated AKS program as well, in which it would be a 3 weekends program for 6 days, and we would be covering a lot of in-depth stuffs. But this would happen after Kubernetes training, okay? So we would be coming up with various programs like this. After learning Kubernetes, if you want to just do the delta, like I want to integrate Kubernetes cluster running in AKS with my Azure AD, with my Ingress application load balancer, traffic manager, container registry, Azure monitor, all those things can be done. I would be the instructor for the program, and we would be running 3 weeks training program for that. Same way, after learning Kubernetes, a lot of people look into automation with Helm. The dates are yet not announced. That's the reason you would see a star mark here. Don't get astonished with that. So packaging and managing Kubernetes applications with Helm. We have a separate 2 weekends program for this, in which you learn Helm's basic installation. You learn how to run basic applications using Helm chart. We also teach you how to prepare your own customized Helm chart. You learn how to write different stuffs like functional blocks, your loops, your variables, and deploy them as a application. So I would be the instructor for this session as well. So we would be coming up with EKS as well. So at present, this training which you are seeing, it would be just for CKA, but going ahead, we are coming up with AKS, EKS, GK, all sort of varied varieties of flavors of Kubernetes, where you learn the delta. The CI/CD part of it is also incorporated in that, so that, like, if you see the AKS one, you would learn how to automate the cluster with Terraform, and you would learn how to do the, I missed that part when I was explaining. That was one of the most interesting part of it. You can look at this, automate your deployment of AKS with Terraform, and even the application deployment we would be integrating with Azure Pipeline, release gates and all to monitor them. So automated monitoring, automated deployment, automated cluster creation, a lot of stuff would be automated in those spaces. But for that, we should be good with basics of Kubernetes. So we are first coming up with that, and then we would be going on to the next set of stuffs. So let me see if any other interesting question to answer without internet connection to how to install Kubernetes without internet connection to easy to instance. Nupur, you would not be able to do that. How will you connect to your server if you don't have an internet connection? Difference between Cubenet and Cni I have done is not a master a single point of failure. Yeah, it's Isaac Prasad, nice question. Failure certainly. And that's the reason in this setup, it was a baby type of setup. So we did a single master setup. Normally we come up with 3 masters for masters high availability as well. So you will have 3 masters set up, and you would have masters highly available too. No, Astha, there is no limitation on the size of the image. You can create big image as well. If I'm not that good in creating image, and I can create a big image and then learn to create small images as well. So not a problem with the size of images. Do we have installment options for making payment? Samuthira, yes, you do have. And you can get in touch with Kopal. Kopal has shared her number with you. So if you can get in touch with Kopal for that, that would be helpful. Yatesh, this doesn't include certification cost because certification itself is $300. So it's very difficult to incorporate that and then run a 8 weeks program. So it is not easy for us to incorporate that certification. But yes, we do have tie-up with CNCF and we have costing reduced for the vouchers as well. So if you wish, you can buy vouchers on a discounted rate from us. What would be the last day to register for the training? It's good that you register early because we would be just opening seats for just 25 to 30 people and we would not be enrolling more than that, Arun. So it's good that you enroll because it's first come, first serve basis. Timing on the weekend, Selvaraj, it is 7:30 to 11:30 India time, IST, in the evening. Any other questions, Shivam, Kopal, you think we need to pick up? Or are
there are some questions in the which are coming through the YouTube.
Okay.
The question will be, it's about, do we cover OpenShift platform since it has Kubernetes incorporated?
Okay, no, we don't because Kubernetes enterprise version is OpenShift and OpenShift installation steps and quite a few numbers of steps differ. But yes, I'm a Red Hat certified instructor as well and we are partnered with Red Hat. So we do deliver OpenShift training. In case you're interested very much in OpenShift, you can just drop us a message saying that you're looking for a OpenShift training. We would have your name in the list and when we have a good batch size, we would announce a date for that as well. So in case they are interested, they can surely get in touch with us.
Okay, thank you.
Any other questions or we are good? There are a lot of people still online. Guys, if you guys have still any questions pending, just let us know. We would love to answer that.
If there are any questions which comes to mind, you can also reach out to us on the event page in LinkedIn. You can post your questions over there. You can message to Mamta as well. She will definitely look up that you get all the replies. And in case there is any question regarding the batch date or installments or anything related to the training which we are doing, then please reach out to Kopal and the links are in the chat window.
There's a question
And
from
thanks everyone for
Nasir.
joining.
Nasir has posted the question multiple times thinking that we are not picking up his question. Nasir, sorry for that. How to use some physical server in one Docker container? Nasir, I think you're trying to ask how to create containers on a physical server. If you have an operating system and you deploy Docker software on top of it, you should be able to create Docker containers on that. In case your question was meaning something else, just re-explain it because I thought you meant that. Sorry, Shiva. Yeah.
Right, so how can we get the recordings of the classes? Now, if you're talking about the webinar recordings, I am just sending the link in the chat window. It's already there. If you can have a look at that, I have just privately messaged it to you. And the recordings are available in the YouTube channel of Tech Scalable. You can find them from there and you can check out our previous recordings as well. And during the session, during the classes, during the training which we provide, the classrooms, if you're talking about the recordings of the training, we record them and it's provided over in a format such as video on demand format. And anyone who is joining the training will be able to get the recording 24 hours, you can say 12 to 24 hours after the session, and you can have a look at them whenever you want.
So all the sessions would be recorded and handed over to you. You should be able to go through the recording of the live classes as and when needed. Mohit, we would be coming up with a delta for CKAD, dedicated CKAD course. I don't think we would be planning anytime soon because CK and CKAD has around 60% to 70% of overlap. So normally when you target, if you're 5 to 6 years experience, you target both the certifications that enhances your profile. So we would be picking up CKA, and then if you want to learn the delta, it would be a short training program for learning the delta. Hope that makes sense. And you can target both the certifications with that. Should I go for CKAD if I have 2 years of experience? Okay. So what sort of experience do you have? You are coming from a developer background, or you are into administration? What type of role you play at present, Mohit? You're a developer, then yeah, CKAD would make more sense for you. Yes, CKAD would make more sense for you, but if you have both, it's no harm. But we don't have a dedicated CKAD program because we don't get a lot of participations in that. We get CKA, huge number of participation, and then people taking Delta. That is the pattern most of the time. So we normally don't have that dedicated CKD session, but just drop a note to Gopal in case we come up with a program sometime in near future. We would surely get back to you. Fine, then I think we are running half an hour up already. So if we are good, and should we close the session, Shivam and Gopal? Are we good?
So we still have 100 online over here and more than 60 in YouTube.
Yeah, true.
That's very.
What's the expectation?
Thanks everyone for joining and staying tuned till the end. And we'll definitely, we have organized in past, there are lots and lots of sessions which we have organized in past and in future as well. You can reach out to us on the LinkedIn page. You can follow us on LinkedIn, and if we do any more webinar in the future, you will get the updates from the LinkedIn. And if there are any more questions, please do let us know about the questions, or we will see you next time.
Yeah, fine, guys. Take care. Still had an enjoyable session, and maybe we'll come up with more webinar series like this, because I saw there were a lot of questions and a lot of participations from your end. That really makes us happy, and thanks for turning out this event to be so nice for us. Thanks for your time and patience. So we would be closing the session now. In case you have anything, you can get back to us on our LinkedIn page, event page. A lot of ways to communicate with us. You can get in touch with me, Shivam, or Gopal, any one of us. Thank you. So Shivam, I'm closing the session.
Okay.
Thanks, Gopal. Thanks, Shivam.
Thanks, everyone. Thank you so much.
Thanks, Mamta. Thanks, everyone.